Welcome, Mastery Algebra 1 students. I am Mr. Fuller, and in this lesson I am going to teach you how to isolate a variable. This is Lesson 2.5 from Chapter 2, Section 5. In the introduction here to this lesson, it says that the process of taking an equation with two or more variables in it and solving so that one of the variables is by itself is called isolating a variable. What happens is, instead of getting a number when you solve, like x equals 2 or y equals 3, you get a new formula, and the formula expresses the value of one variable in terms of the others. The title of this page kind of gives it away that we're going to be solving for y, and then we're going to have x or any other variables on the other side. One common use of that skill, or this skill, is to help when we graph lines. For example, 3x minus 2y equals 6 is the equation of a line in what we call standard form. When we graph, though, we commonly use the slope-intercept form, which looks like this: y equals mx plus b. Notice that it starts with y equals. So we want to turn equations that look like this, where it doesn't say y equals, into an equation that looks like this, which does say y equals. That's really the concept behind what we want to do here. How do we isolate the variable y so that we end up with y equals? So let's start our investigation with the equation 3x minus 2y equals 6. Part A here says substitute the value x equals 4 into that equation. So I'm going to replace x with 4, and that's going to give me this. Of course, 3 times 4 is really 12, so I probably should have just written 12 minus 2y equals 6. Now to solve that, I can subtract the 12 from each side. That would give me negative 2y equals negative 6. And then when I divide both sides by negative 2, I'm going to end up with y equals 3. See, now this time I did get y equals 3. That's a number because I put a number in for x. The same thing will happen in the next problem. In the next one, it says to substitute the value x equals negative 6 and then isolate the variable y. So if I plug in negative 6, when I multiply by 3, that will be negative 18. Since space is kind of limited here, I'm just going to go ahead and write the negative 18. Now I need to add that 18 to the other side. I have a little bit more room to show my work this time. That will give me negative 2y equals 24. And then when I divide by negative 2, I will get y equals negative 12. Again, I am getting a number for the solution because I plugged a number in for x when I started. What we want to do in part 2 here, where we have the thinker man on the side, is we want to take that same exact equation, 3x minus 2y equals 6, and solve it for y without plugging a number in for x first. So we want to have an answer that still has x in it. Well, let's think about what we did to solve these. The first step in the process was whatever the number was that 3x made, we had to subtract it. In this problem, 3 times x gave me 12. I had to subtract 12 from each side as my first solving step. My second solving step was dividing by negative 2. In part B, the first thing I had to do was, since 3 times the x number made negative 18, the first thing I had to do was add 18 to each side. In other words, what we're really going to have to do is get rid of the 3x. And it kind of fits common sense. If I want the y to be by itself, I got to get rid of the 3x. So if I start with 3x minus 2y equals 6, how do I get rid of the 3x? Well, how about if we subtract it? It's a positive 3x. Here's where we have to be careful. Are 6 and 3x like terms? No, they're not. So I have two options here. I can either write 6 minus 3x, which is tempting because that's the way it looks, or I can write negative 3x because we're subtracting the 3x, plus 6 because the 6 is a positive. I like this method better because it's more consistent with the slope-intercept form that we're actually trying to get. And then the next step in each of the preceding problems, the last step really, was to divide both sides by negative 2 because there was a negative 2 in front of the y. So basically that's what we want to do now. We want to take each side and divide by negative 2. Now really what we have to do is we have to divide everything by negative 2. So in a way, it kind of feels like we're dividing by negative 2 twice on one side and once on the other. But basically, we're just dividing every number by the negative 2. So on the left-hand side, negative 2 divided by negative 2 makes 1, and we end up with 1y. That's what we want. Equals, and now we have to simplify the right side. So in front of the x, I have a 3 on top and a 2 on bottom, and they're both negative. Negative divided by negative makes positive, and so we get 3 over 2 in front of x. And then at the end, we have a positive 6 divided by a negative 2. That makes a negative 3. So here is the equation in what we call slope-intercept form. It's the same equation that we started with, just written in a different form. We isolated the variable y. Isolating a variable works exactly like solving a normal equation in one variable, except that occasionally you need to add or subtract a variable or an expression rather than just a number. So instead of just adding a number or subtracting a number or multiplying by a number or dividing by a number, sometimes you have to add an expression like 2x or subtract an expression like 3x. So now we're going to use this principle to solve these next two examples. Let's do these next two together, and then I'll let you try the rest of this activity on your own. So 3x plus y equals 1. If we're isolating y, the only thing we have to get rid of is this 3x. So it makes sense to me if we just subtract the 3x, it will be gone. So on the left side we'll have only y, and on the right side we can either write 1 minus 3x, or the preferred way to write it would be negative 3x plus 1. That is completely solved. It says y equals. We isolated the variable y. In number 3, we still are trying to isolate the y, so there's two things to get rid of this time. We have to get rid of 3x, and we have to get rid of 2. So to get rid of 3x, we just need to subtract it. It's a positive 3x right now. And when we do that, we need to remember that 6 and 3x are not like terms, so we keep them separate. We have a negative 3x and a positive 6. And then we have to divide everything by the 2 that's in front of the y to isolate the y. So now y equals, this time we have negative 3 halves in front of x and positive 3 at the end. 6 divided by 2 is 3. And that, my friends, is how you isolate a variable in the standard form of an equation. So now you have problems 4 to 9 to practice this. So pause the video, work those 4 problems, and when you're ready, start the video again, and you can compare your answers with mine and see if you are understanding this. Here are the answers to 4 through 9. Take a moment to check to make sure that you agree. Look especially at the fractions in number 8 and number 9. Both of the terms have fraction answers in those two. Do your best to figure out how to get these answers if you don't have them, and ask whatever questions you need to when you get the chance in class. Next, we're going to look at how you solve, how you isolate a variable in equations that actually have no numbers, or they have multiple variables more than just x and y. So let's take a look at number 10. Number 10 says c equals pi times d, and it says to solve that for d. That means we want to end up with d equals. So to get d by itself, what I'm going to have to do is I'm going to have to divide both sides by the pi. Since d is multiplied by pi, it makes sense that to solve I have to divide by the pi. So c divided by pi makes d. And that is the answer to number 10. In number 11, I have to solve for s. So I have to end up with s equals. So in this problem, I have to undo squared. What's the opposite of squaring? Well, that would be taking the square root. So if I take the square root on both sides, I get the square root of a equals s. And that is the answer to number 11. Go ahead and try 12 and 13. Pause the video and try those two problems. When you're done, turn it back on, see how you did. The answers are actually at the bottom of the page, but you'll also be able to see the steps when you come back. Here you see the answers to the last two, 12 and 13, along with the steps. Make sure you understand how those work, and ask any questions you need to in class. That's it for this lesson. Thank you for tuning in. Do your best, forget the rest. Bye for now.